Hey guys, welcome to my first, we'll call them quarantine videos, I guess, for lack of a better word. I'm sure I'll talk about it in class, but obviously I am on contact tracing quarantine. My hope is to be back as soon as possible to be back with you guys in the classroom. It obviously kills me not being there to enjoy the time with you guys. Congratulations to the girls' soccer team on an exciting win last night. I was able to stream a portion of that game and watch some of that. So, very exciting. Congratulations on your CHL championship. Um, so, let's just kind of work through this problem, I guess. This is kind of how I'm going to try to make things operate for the next couple of weeks is getting videos out like this where I'm working some example problems and then you guys are basically going to have the time to work on that chapter packet. Very similar to the structure class would have. Only issue is we obviously can't necessarily ask questions during the video. If you do have a question, what I plan on doing is having the video up during class on one of my devices, either my laptop or my iPad, and then you guys can hop on Zoom and chat me questions. So the way I envision this going is basically you're watching the video on your device. Let's say at minute 3 of the video, you aren't understanding something and you're not sure where I got that number. You know, Mr. Murphy, why did you use sine and not cosine? Something like that. What I would do is I would pause the video where you're at, hop onto Zoom, send me a chat and say, hey, I'm having trouble at this, the 3 minute and 30-second marker or something like that. And then we can either chat about it via Zoom or I can even create a breakout room for me and you, and we can discuss further in detail what it is exactly you're struggling with. I ask that you guys be flexible with me over the next week and a half or so as I obviously work through this. I do feel fine. I feel great right now, so I'm hoping to be able to Zoom every day. But be as flexible as possible. Obviously, this is something I'm new to, and it's something that you're new to as well. So, without further ado, in light of tonight's soccer game, we'll go ahead and work through this problem. Okay, so in a soccer game, a player runs straight down the field for 15 meters. The player then turns at an angle of 22 degrees to the right of his path and runs an additional 8.2 meters. He then turns and runs directly toward the right side of the field for 5 meters. Okay, find the player's resultant displacement. So I did start to sketch this down here at the bottom. I forgot to put in this last part here, which said turns towards the right side of the field for 5 meters. So just kind of looking at our picture here, we have our 3 vectors. Vector 1, V1 right here, okay? Vector 1 is that 15 meters when he's running straight down the field. Vector 2 right here, okay, is that 8.2 meters that he runs at the 22-degree angle. And then vector 3 right here is the 5 meters that he is running 5 meters he is running at that 90-degree angle to the right, directly at the right sideline, okay? So similar to what we've been doing here, this is a more complex question because there are 3 vectors we are looking at, okay? Vectors 1, 2, and 3. The ones I'm going to ask you guys to do are only going to involve 2, but it's not really much more work to add a third, and it's a question that I found in a bank of old questions we have from physics textbooks and stuff, and it's one that I liked, especially in light of the soccer game, so I thought I'd use it anyway. So first thing to do is we are going to we want to know the resultant distance here. Not a very straight line. We want to know that R. Okay? And to do so, we are going to break this into X and y components. Okay, so we're going to break this into x and y components. All right, and I'm just going to work one vector at a time. Okay, so for vector 1, okay, this vector down here, I'm going to put 0 for that vector's x component, okay? The reason that is that vector is acting straight up and down, okay? It is not acting at all in that horizontal direction, okay? It is acting strictly vertically, not at all in the horizontal direction. So it has a 0x component. Its y component is going to be the 15 meters. Okay? So that one's pretty easy. Skipping up to vector 3, I'll come back to vector 2 here in a second. That's the one where we have to do some trig. Vector 3, as you might guess, acts completely in this x direction. Okay? So we are going to come here, and I'm going to add my 5 meters for my vector 3. Okay, and for good measure over here, I am going to put 0 meters. That way I know that there is no y component, or there is a 0y component in that third vector. Okay? So vector 2 is where things start to get a little bit fun for those of us that are into math. This is the one where you actually have to find x and y vectors for. Okay? So I am going to draw kind of the imaginary triangle we are going to look at. I know that the hypotenuse of this triangle, this second vector, is 8.2. And I know that down here, my angle is 22 degrees because I went and turned 22 degrees to the right of my path. Okay? So I know my 22 degrees and I know my 8.2. Here is my x component of that imaginary triangle. And here is my y component of that imaginary triangle. Okay? So I'm going to kind of give myself a little bit more space here. If I go into this imaginary triangle, let's first find this x component right here of that triangle. Okay? So in order to find that x component of that triangle, I know that this is opposite of my 22 degrees, okay? And I know my hypotenuse down here, right? This 8.2. Okay, so I know my 8.2, I know my hypotenuse, and I also know that I am looking for the opposite, okay? So if I look at my acronyms, SOHCAHTOA, okay? I am looking for the one that has opposite and the one that has hypotenuse, okay? So I'm going to use sine. All right, so when I go to set this up, sine equals opposite over hypotenuse, okay? Next step, I'm going to put in my angle, okay? So it's going to be sine of 22 equals opposite, okay? Opposite's what I'm looking for, over my hypotenuse. My hypotenuse is that 8.2, okay? So I have sine 22 equals opposite over 8.2, okay? I did happen to locate a calculator. All right, so I'm going to type in sine of 22. Okay, the important thing when doing this math, guys, make sure you take the time, take your time doing this. When you do this, I always type in sine of 22, enter, times 8.2, enter. Okay, that way I know I am getting the right number here. Okay, if you type in sine 22 times 8.2, you're going to get the wrong answer, okay? So just make sure you're taking your time and doing that very carefully. So when I did that, I got my opposite to be 3.07 meters. Okay, so I now know that this component right here, this x, is 3.07 meters. Okay, I'm now going to look for my y. We are still going to use this 22-degree angle right here at the bottom. All right, my y is adjacent. Switch colors for you. Okay, my y is adjacent to this 22-degree angle, right? It's right there joining it. Okay, so it's adjacent, and we know the hypotenuse, so I'm going to use cosine for this trigonometric function. Cosine equals adjacent over hypotenuse. Okay. Now we just plug in what we know. Cosine of 22 equals, adjacent is what I am looking for, over my hypotenuse, which is 8.2 meters. Similar to last time when I typed this in my calculator, I'm hitting cosine of 22, enter, times 8.2, enter. Okay, that gives me an answer of my adjacent being equal to 7.6 meters. So this is going to be 7.6 meters. Okay, so I now found the x component of this triangle and the y component, x component of this vector and y component of this vector, okay, vector 2. All right, so I can go ahead and put this back into my equations over here, or my x and y components that I have separated things into. Okay, so like I said, our x component up there was 3.07 meters, okay, and I am just using this number up here, that x component that we found. All right, my y component right here was the 7.6 meters. Okay, I'm going to go ahead and add those up. Makes my x component 8.07 meters. And my y component 22.6 meters. Okay, so pretty straightforward so far. I think most of that, it's probably a little bit difficult for you. It's only the second time you guys have seen some of this. But like I said, I encourage you guys asking questions. If you have questions, please feel free to type them in the Zoom chat. While you're watching this, I'm more than happy to respond to you via chat, or we can even make some sort of breakout room to try and assist you that way. Okay, so I have my x component, I have my y component, so now I can do Pythagorean theorem. So what we really have here is we have, or the way we're going to solve this rather, is a squared plus b squared equals c squared. Okay, and I knew I was going to do that at some point. Running out of room. Projectile motions next week, lots of fun. Okay, a squared plus b squared equals c squared. Okay, x component 8.07. Okay, squared, plus my 22.6 squared equals c squared. Okay, go to your calculator, type that in. Square root I got 23.99. So I am going to go ahead and round my C to 24 meters. Okay. Okay. So my resultant vector then, okay, this vector right here is 24 meters. Okay. So I'm going to kind of start this right here. Resultant vector is 24 meters. Okay. So remember, all we did there was we created kind of this big triangle all the way around with this dashed line. So I'm going to kind of highlight it in yellow. All right, this right here is the big triangle that we just created. Okay, you knew the 5, you knew the 15, you found the y via trig, you found the x via trig, okay, and then you used Pythagorean theorem to get your r. Okay, that's all you did. I know it was a lot of steps. I know some of it sounded a little tricky, but it's not as scary or as intimidating as you might think. Okay, so the last thing to do is to find this angle right here. Okay, this angle right here, I will call it theta. Okay, for those of us that are good math wizards, math practicers out there, I will call it theta. Okay, you can find this by doing any of the trigonometric functions since you know all the sides. I will choose to use tangent. Okay, so tangent, inverse tangent equals opposite over adjacent. Okay, the opposite was this x component right here, right? Opposite is the x component, so when I do this, the x component is 8.07 divided by the adjacent right here is this y component, right? It's the one adjacent to the theta. All right, so that was a distance of 22.6. Okay, so when you go to your calculator, make sure you hit second tan and then type in 8.07 divided by 22.6. Okay, that is how you are going to get your angle, second tan. Okay, and once you do that, you will get your angle to be equal roughly 19.7 degrees. Okay, so I'm going to come down here. Resultant vector is 24 meters at 19.7 degrees. Okay, and that is this direction right here, right? So that is going to be east of north. Okay, so the resultant vector is 24 meters at 19.7 degrees east of north. And it's east of north, right? Because if this is the north latitude or the north longitude or however you want to call it, okay, we are going to the east of it, okay? You are traveling to the east of that line. Okay, and that is how you can find your theta. All right, so one question is as simple as that. I tried to explain it as best as I could there. Like I said, if you have questions, please feel free to pause the video, rewatch a portion that might have confused you. And I encourage anybody and everybody to join the Zoom, ask me a question via Zoom, whether that's on chat or me creating some sort of breakout room so we can talk privately on Zoom if that makes you feel more comfortable. Outside of that, you guys have a 4-day weekend, no school on Friday or Monday. So I hope you guys that you are enjoying, or sorry, I hope you guys enjoy your weekend. Yeah, and then if you guys have any sporting events, I know some of us maybe had tennis today. I'm sure there's a soccer game over the weekend at some point. Best of luck to all of you guys competing in all of your sports as your guys' tournaments approach here. So, thanks for your time, guys. Have a good day.